Hello folks, let's come back with the next part of this exercise 7.4 where we have these problems like similar kind, but some are a bit complicated, but the others are more or less very simple. If you know the formula, you can substitute. So here we have the root formula. We know that we should get it in that form. This should be working as a squared root of a squared minus x squared. Let's bring it in that form and then apply the formula. So this is going to be integral of dx. This could be very well written as 3 squared minus 5x the whole squared. See, you could substitute u as 5x over here, but then that's it's okay. It's only that you have to be careful about the integral coefficient 5. That's all. The others is going to be quite simple. So maybe we will do it without substituting, but with substitution also. For those who feel that no, it's going to be tough, please substitute u as 5x and then proceed. You'll be able to get the same answer. All right, so when we see it, this is of the type integral dx over root of a squared minus x squared. And we know that if it is of that form, then the integral is simple sine inverse of x over a plus c. So let's get across doing it. It's nothing at all, right? So let's write the integral is sine inverse of x for us is 5x over a for us is 3 plus c, but then we have to account for this integral for coefficient, which is 5. That's all. So 1 over 5 sine inverse of 5x over 3 plus c. There are chances that these kind of problems come in the MCQ. So the attempt is that how well you're able to apply the formula so that you can really save time. That's how it is. It's nothing at all. As I told you, if you're not comfortable with directly doing it, then you can make a substitution u as 5x and then work. Then it will be very comfortable for you. But then this is also relatively simple. It's quite relatively okay. Fifth one, let's take. It tells that it is 3x over 1 plus 2x raised to 4 dx. This we have to do a little delicately. So it's not so difficult, but then we'll have to take it a little delicately. Now we'll see that in the denominator, we know we want squares, right? So that is our target. So maybe we will keep it as, let this 3x dx, let it be as it is. And let's call this as 1 squared because we know that we always want squares. Now if it had to be like this, then we could keep it as root 2x squared the whole squared. Yeah, because we know we want squares, because then only we are able to apply this formula. So now in this case, let's apply u as root 2x squared. So your du over dx is going to be root 2, and for 2x, the derivative x squared, the derivative is 2x. Du over dx is there, that can come here. So what happens is, since we have, this 3, everything is a mess. So let's write this as du over 2 root 2 and let this be x dx. So also when we take the integral, let's be careful to take the 3 out. Let's take the 3 out so that you're left with x dx, which you know is du over 2 root 2. So that coefficient issue is sorted out. And in the denominator now we have 1 squared plus root 2x squared, we had taken it as u, so it becomes u squared. Now it's quite comfortable because you are now of the form dx over x squared plus a squared, and that will work as 1 over 2a, no, 1 over a x squared plus a squared, x squared minus a squared, and a squared minus x squared. So x squared plus a squared, it is tan inverse. Yeah, so this is the formula that we're going to apply. So this is going to be 3 over 2 root 2. A for us is 1, so it's 1 over 1. Tan inverse of x over a. X is u for us, a is 1 plus c. So it is 3 over 2 root 2. 1s and all don't contribute anything. So it's going to be tan inverse of u alone, but u is root 2x squared plus c. Just observe this carefully and see if it's making sense. Next also, it's x squared over let me check. 1 minus x raised, yeah, as I told you, always we are behind the squares, so you have to get it in square form. Yeah, that's going to be our objective. So this is going to be x squared dx. This is 1 squared and this is x cube whole squared. So let's call u as x cube, because that's going to be our natural choice, because we want the square there. So du over dx is going to be 3x squared dx. Yeah, dx I've taken it on the other side. Now when we look at the numerator, we know we want only x squared, so let's push the 3 here. So du over 3 is x squared dx. As a result, when we again revert back to I, you're getting this as du over 3, which is 1 over 3 here, and this is 1 squared minus u squared. Actually, you're of the form integral of dx over a squared minus x squared, which works as log 1 over 2a, log a plus x over a minus x plus c. So let's quickly write what it comes like. So I for us, it's going to be the 1 over 3, which is already there, but you should have the 1 over 2a, and a for us is 1, so it's going to be 1 over 2. Then it's going to be log 1 plus u over 1 minus u plus c. So it's like 1 over 6 log, let's revert back, 1 plus x cube over 1 minus x cube plus c. 1 over 6, yeah. Yeah, that should be all for this video. Maybe with more problems, we'll meet in the next video. Thank you.